Hello and welcome to Think Tech, a science, technology and innovation program structured to track Nigeria's technology development trajectory in all its ramifications, from ICT to nanotechnology, virtual manufacturing, reverse engineering to recycling and general science-driven production systems. The program is also designed to take you on Nigeria's journey to technology acquisition, adaptation and promotion as a way of highlighting drawbacks, neglect, and the expected reawakening of national interest in science and technology, plus, of course, the role of individuals and research institutes in the development of science, technology, and innovation in Nigeria. Today, we are focusing attention on local manufacturing of machinery, virtual manufacturing process, patenting of products, and the process of reverse engineering. All that in today's edition of Think Technology. I am Kierian Umeayo. Thank you for joining us on the program today. For a start, let's take you to a technology farm here in Abuja where indigenous fabrication of machines is practiced. Meet architect Christopher Egudale, a farmer, civil servant, and fabricator of machines.
Christopher Egudale is a typical example of a Nigerian with a burning desire to research, design, and fabricate multi-purpose precision machines using local materials and expertise to achieve his objective. His technology farm is located in the slope of Mpape Hills, where he has been practicing construction of machines for over 20 years. At the time of a visit, some of the machines had become dysfunctional due to lack of funds to carry out the necessary repairs to put the machines back on track. He told Think Tech Crew that because of paucity of funds, he could no longer offer training to younger Nigerians on the art of machine production. He was, however, optimistic that a change would come to rescue the technology enclave from its present state.
This is a pulverizing machine. This is my creation. Unlike some of the machines that you have seen, they are reverse engineering, but this was my creation. I came about when I was doing some jobs. Somewhere I had to build an estate in bricks. So I discovered that the laterite was being wasted. After sieving the laterite, it's quite a lot of manual labor to sieve the laterite. And after sieving, the lumps that comes out are usually wasted. So in a trip of laterite, for instance, you get maybe about 1,000 bricks, and the rest of the laterite is wasted. So I now created this machine. It will break the laterite. After breaking the laterite, then it will sieve the laterite. So you can use the whole trip of laterite, thereby reducing the cost of the bricks. So that is the work of this machine. It's a milling machine. It's used for fabricating gears and a lot of things in this thing. Make screws. You can do a lot of things with this milling machine. So this is one of the crucial machines in the fabricating industry, the milling machine. Okay, so this machine is called a lathe machine. I have two of them here. I have a small one and I have the big one. This machine is also used for making pulleys, pistons, a lot of things, anything that has an axis. This machine is used for producing them. Here is a bending machine. This is a bending machine. Used for making, like, you want to do container, overhead tank, tables, also all to bend a flat sheet, to make them bend into shapes. This is used for doing that. It's a bending machine. It can bend up to 10 mm, as it is thickness of metal. Okay. This is a drilling machine. It's used for making holes into metal or wood or anything. It's for this, in case you want to do threading, you also use it for this thing.
From all indications, the challenges confronting the growth of indigenous technology are enormous. First, the funds are not readily available to support research, and necessary tools for construction, as well as configuration of machinery. There is an unquenchable desire for foreign-made machines, leading to low or even zero patronage of locally fabricated ones, plus absence of commercialization of research results that have the potentiality to trigger successful production of locally made wood-class machinery. Some Nigerians, like Christopher Egwudale, are not giving up, believing that technology revaluation is the answer to the problems in sectoral development in Nigeria.
Work when I'm doing here is site improvement. Anything generator, all the machine where we are using, all those engines, I'm the one maintaining it for past 10 years to this time when we are working here.
From your experience,
Yes, sir.
do you think that there will come a time when Nigeria can, manufacture its own machinery based on your experience here?
Yes, sir. Thank you, sir, for your question, sir. If we can see the way when our guy is doing here, if we can see a lot of Nigeria people doing what he's doing, all we youth for this country, we do so very benefit a lot of things. But we have nobody where it's just only this guy just try for us to be doing all these kind of things where we say if we reach out, we see small things to be feeding our family. I want to beg our country, if they can help us, when our youth, we are just there here for nothing. But can you see the way when our guy is doing something here, everybody we are busy, a little. See the concrete mixer we are manufacturing concrete mixer here, we are manufacturing a lot of things here, molding machine, different things, different type of equipment, we have it here. I want to beg our country people, may they just help our Oga with a lot of money to still establish more than this for us. Because if the Oga can have money to manufacture all these things more than this, everybody will be busy. I can remember there is a time, when we are working here, we are more than 500 people workers when we are working here. But now, there's nothing going well like before and again.
Think Tech caught up with a Port Harcourt-born Filipino-Iranian, Afshin Farunzan, an economist by training, but a technology enthusiast who developed skills in the repair and construction of drones. He says technology runs in his family's DNA.
Well, my view in Nigeria is that basically as long as you give somebody an opportunity, they can always have that chance to do the best with it, right? Like Nigeria is already a country wherein we have our independence. We don't need to rely on other countries in order to bring in stuff that we would actually need on our day-to-day work. Like for example, if we need bricks now, we don't have to import them from abroad. We actually have the machines here now that can make them at a cheaper cost and also use part of Nigeria's raw materials as well, because we don't need to import everything from China, because nowadays the quality is low, the standard is low, but then we're paying so much for it. Not just that, but we're also paying taxes and we have to wait so much longer. We're not even sure if those people are going to come through with their promise or make it the quality that we want. Like nowadays, the problem in Nigeria is just low quality everything. And I believe all of that just started from people who import and export, right? Like there's no more standard quality check, but at least if you look at this now, like this house was built here with our own brick making machines, and it barely cost as much as it would have taken if we were to have hired or brought in resources from abroad, right? Like the future is now in Nigeria, and it doesn't matter whether you think we know how to do something or not, because you can always train somebody. You can always teach somebody how to actually use the machines. It's not something that you need to go to school for it, because at the end of the day, if somebody has a passion for something, then they would excel in it, whether it was their course or not. As long as they have a love for something, then they can really push boundaries.
Available records indicate that there are many Nigerians who have acquired skills in machine fabrication and who have made machines of different forms and sizes for different purposes, hoping to get the funding or have their products commercialized for the benefit of Nigerians. Today, we will learn about virtual manufacturing, a process that has been perfected by staff of National Agency for Science and Engineering Infrastructure. It's a sophisticated production method with precision and accuracy, most efficient, and the current global approach to modern manufacturing. Bayomi Adesala is our guide.
You're welcome to the Virtual Manufacturing Laboratory of the National Agency for Science and Engineering Infrastructure. Here in this laboratory, we have engineers from different fields, ranging from mechanical to civil to electrical, to all fields of engineering, are working together to bring out parts and components of various different equipment. Here, we do the design, analysis, and e-manufacturing of parts before we commit any material into them, meaning waste is eliminated and margin of error is very, very low, because before we commit any material into it, we actually do the simulation, design and simulation of the component and see how it will come out when it's finally being produced. And it makes the work easier and flexible, because we can actually do a lot of changes as we go on in the design work. We'll just briefly do a demonstration of one part to show us how this equipment here work. We have different software coming together to form the crust of what we do in this virtual manufacturing laboratory of the National Agency for Science and Engineering Infrastructure. Here on the screen we have a gear that's been designed. It's a gear, a part of the gear train of a tractor. So we're going to show you how this process of e-manufacturing is done using this particular gear. Here, we're taking it from the design stage. The design has been done, and we have it here. We're going to cut the gear from this blank we have here. So let's just quickly go to that part of it that cut and generate the code. Here is a blank workpiece where we're going to cut the gear from. Now, as we go on, the system is going through using the tool to cut the gear just like you have it on a CNC lathe. Doing the cutting of the gear, it's a milling process actually. Doing the cutting of the gear, every stroke of this is recorded at the back end of this system, and that is what actually will be retrieved at the end of this cutting when the job is certified as perfect to what we want it to be. Then the code can be retrieved and then from there sent to anywhere in the world for the actual manufacturing.
Reverse engineering is an integral part and process of technology acquisition globally, and in Nigeria it's a process that its potentialities are largely untapped. But there are signs of improvement in the advancement of reverse or back engineering, as it's referred to in some quarters, to enhance the nation's growth in local manufacturing of technology-driven products. I took up Professor Mohammed Haruna of Naseni on this with a view to eliciting information on the legality or illegality of reverse engineering practice and how it can impact on local technology.
Reverse engineering is another term for copy engineering. It means you see a product that is technical in nature and you want to reproduce the same. You want to copy it and produce it. That is exactly what it means. You want to duplicate what you have seen. Generally, it is something that you don't know how to do it before, but you want to learn how to do it. But you want to apply engineering principle and method in producing the same product of the same quality.
Now, what are the basic steps required to achieve efficient reverse engineering?
The stages involved in reverse engineering. First and foremost, you have to analyze and understand the functionality of the equipment, and also refer to the sciences and the engineering and principle in which the equipment is operating. Next is to dismantle the equipment carefully while taking note of how everything is assembled. In doing that, you make label and marking to ensure that when reassembling it, you won't miss any part. After doing that, you attempt and you produce different components that make up the system or machines. That is in traditional way. But the method of doing that has changed with modern and advanced technologies. In modern days and advanced manufacturing processes, all you need to do is to have a machine to scan the equipment with accuracy. It will scan it, provide all dimensions accurately, and give you the readings without having to use manual means of tape measurement or ruler to measure component. What is generated during that scanning becomes a computer code which can be transferred to a machine that is a computer numerical control or CNC machine to reproduce the same thing. However, before then, you will want a 3D version of that from a 3D printer so that you will check whether the shape, size, and everything is exactly like what you want to reverse engineer. In addition, the process provides you an opportunity to test performance on a virtual manufacturing machine. That is, by visualizing exactly what you want to produce, you see it pictorially in 3D model, and you also operate it virtually, test performance. If it is a car, for example, you will cover certain kilometer of riding in the laboratory as if it is in the real world. In the process, you will identify components that are likely to fail and select from the library of parts the appropriate equipment or combination of materials or alloy of materials that will give you performance exactly as the original machine you want to reproduce or even better. The beauty of the facilities for doing reverse engineering now is that you can optimize, you can test performance, you can assume and make it as if it is in the real world, virtually, running hours of thousands of hours, if it is an aircraft of thousands flying hours, if it is a drilling machine or an harvester, you do the real job that the machine is supposed to do while measuring the likely. It will indicate to you likely area of failure because of the component you select. And by selecting appropriate component, it will give you the performance it should be. And if you abide by that and transfer the code, the material selected, to computer numerical control or called CNC machine, there is CNC milling, there is CNC grinder, everything. Any of these machine that is appropriate for the production of the machine you want to reverse will perform, will produce the equipment exactly as you selected virtually. And when you come to the real production, there will be no waste. There will be accuracy as exactly what that machine. In fact, the accuracy is 100 plus.
Is it legal to integrate features from reverse engineering program into another program for commercial or non-commercial purposes?
Well, actually, if you see anybody's machine and you want to reproduce the type, the intellectual property rights require that you have certain permission and certain understanding on that. Of course, in the world, everybody copy legally and illegally in order to produce their own. That is how the Japanese have grown. That is how the Chinese have done, copy other people's technology. But of recent, what people do, even if you don't have legal right, you do certain different variation. You improve certain features, or you develop new features that are not in the original machine, such that the owners of the first one will not accuse you of copying their equipment. But everyone in the world, including the West, have copied one product or the other in order to develop their own. So in the engineering world, it is said, borrow it, copy it, develop it, and produce it by any means, legal or illegal. Make it legal, because nobody has monopoly of engineering and technology. Everybody is copying from others.
And from reverse engineering to patenting, which is a prerequisite for owning intellectual property. Patenting is an exclusive right to a product. And today on Think Tech, we sought to learn more about the concept, types of patents, the process of obtaining it, and what can and cannot be patented. Let's now talk to Dr. Dan Azumi Ibrahim, the Director General of NOTAP, an agency responsible for patenting of Nigerian products and services.
Patenting is like you are protecting the intellectual assets you have. All the manufacturing processes are products of research and development. Somebody had spent time, or some team have spent time, money, and resources to come out with a process. And if you don't protect that process, like somebody can take that same process and makes use of it and makes money with no litigation whatsoever. So what is important is when you come up with any innovation that could translate into products and services or processes, you have to protect it because it's your intellectual asset. More than 90% of the technologies that power the Nigerian economy are imported technologies. And these are products of research and development from other developed nations. So for us as a nation, if you want to remove the level of dependency on foreign technologies, we must have to sensitize our researchers on the need for them to protect their intellectual assets. What is happening now is most of the researchers, whenever they hit any jackpot, whenever they hit any innovation, they are in a hurry to tell the whole world that yes, we have done that, and they publish it. Once you publish it and it comes into public domain, you have no monopoly whatsoever in the intellectual assets.
What is the nexus between manufacturing and patenting of products?
A researcher can undertake a research and come out with results, either in process technology or in any services. You understand? But the researcher doesn't have the fund, doesn't have the wherewithal to translate that into product and services. Private sector must have to come in. And private sector can only come in and invest in any property that is well protected. It's like you have a plot or a plot that does not have certificate of occupancy. Anybody can encroach on that. But if you are able to protect that intellectual assets, somebody now is assured that when he puts his money or her money, they are going to have the monopoly of that information, the monopoly of that knowledge, and translate it into money. So it is the first stage, in my own opinion, of commercialization of any research and development endeavor.
Nigerian manufacturers hearkening to your advice on the relevance of patenting their intellectual property.
Majority of those industries that are operating in this country are multinationals, and their research and development activities are mainly taken outside the country. So they don't seem to, in my own opinion, very few of them, they don't seem to have responsibility to ensure that what is coming out from our research and development endeavors translates into product and services. The only companies that would do it, in my own opinion, are indigenous companies, Nigerian companies, because Nigeria is their own country. The resources that is used to come out with this innovation through research is a resource from their own country, and they have responsibility to ensure that they promote what is developed in Nigeria. In my own opinion, only indigenous companies like Dangote and some of them that have been here for a very long period of time, like PZ Nigeria Limited, they've been trying honestly. So, but to expect most of those international companies to latch in and now see how they can now transform our R&D products into services, it is highly unlikely.
Now, here is something to share with you before we conclude today's edition of Think Tech. With the creation of robots, particularly industrial robots, people became apprehensive about machines taking human jobs. But today, industrial robots are believed to be clumsy, according to experts. This is because industrial robots can repeatedly pick up a component on an assembly line and deposit same appropriately with amazing precision and without getting tired or bored. But move the object half inch or replace it with something slightly different, and the robot will fumble ineptly. Ponder on this as we wrap up this edition of Think Tech, Think Technology. Thank you for watching. I am Kierian Umeayo. Bye for now.